Okay, this is the second video of chapter 9 about hypothesis testing. In the previous video, I explained the, the underlying philosophy approach to a decision-making process, right? You have to choose yes or no to a research question based on data, right? And it was similar to the presumption of innocence or paradigm shift in science and like your shopping pattern. Like today, I will think about another interesting example. So think about a free cancellation policy from an airline, right? So suppose that like a lot of customers have many things, many unavoidable reasons to cancel or cannot make a trip to the airport or have to cancel the trip. So an airline offers free cancellation policy, and the airline believes that like the probability of unavoidable cancellation is 20%, right? Reasonable cancellation, right? So like if the traveler is sick or there was some literally natural disaster, something like that. It's not intentional cancellation, but unavoidable, reasonable cancellations. And we assume that cancellations are statistically independent. We considered very similar example from the binomial distribution chapter in chapter 5. Okay, we are using pretty similar example. Now the problem is because the cancellation is free, some people abuse the policy. That means they just make a lot of reservations that they know they are going to cancel, right? So make unnecessary reservations and cancel in the last minute or cancel later. So that causes like problem to the airline. So the airline tries to identify those abusers and planning to deny them from the pre-cancellation policy. So will they don't allow free cancellations to those abusers. It is it is another kind of decision making. You have to tell a customer is an abuser or innocent. It's like trial. Okay, so I will give you a simple data, simple uh, observations. Suppose that there are two customers which, that canceled quite a high percentage of their reservations. So customer A canceled 3 reservations out of 5, and there is another customer B, who canceled 30 times out of 100 reservations. Okay, so who do you think is more likely to be an abuser among these two suspicious customers? If you have to compare them based on the data and based on these assumptions, like independence and 20% cancellation probability, who do you think is more suspicious? Uh, there is no correct answer. You can think differently, but I will. I can guess what you think. I guess you will think customer A is more suspicious because the cancellation probability is 60% for A, but only 30% for B. So customer A is twice more likely to cancel the reservation than B. But let me explain the other way. I I think customer B is more suspicious and in a statistical sense. Let me explain that. What I'm going to do is I will suppose that both are not abusing the policy. So that is possible, right? Because cancellation probability is anyhow 20%, even though they are not abusing the policy. So it is possible that customer A canceled 3 times because of some rational, like reasonable reasons, right? So something bad could happen. Just customer A was just unlucky. It's possible, right? So what I'm going to do is I will use the binomial distribution. We will calculate the likelihood of reasonable cancellations following a binomial distribution, right? So for customer A, the distribution of reasonable cancellations with like out of 5 reservations. So out of 5 times, how many times an innocent customer can cancel the reservations? So this is probability. So 32% will not cancel any, but nearly 41% will cancel 1 out of 5 reservations. And as you can see, there are positive probability. There is a positive probability 0.03% that an innocent traveler can cancel all the reservations, all the 5 reservations. Super unlucky traveler, right? So always something happens. And then this is a distribution, even though no one is abusing the policy, right? And still, you can see that these guys are very suspicious, right? Even though the truth is innocence, they are innocent, but they look very suspicious on the surface. Okay? So then, now let's think where the customer A is. Customer A is here. So then, of course, based on the distribution, you can clearly see that more cancellations mean more suspicious, right? Right? So then you have to ban some customers from free cancellations from the most suspicious group, right? You may, if you ban the customers who cancel all 5 times, you are going to ban 0.03% of customers, right? They are the most suspicious guys. And the next suspicious group, who canceled 4 or more reservations out of 5 times. They are, so that is those two groups, 5 cancellations plus 4 cancellations, and their probability is 0.67%. 0.6% of customers will be banned if you choose cutoff at 4. If you are to ban more customers, then you are going to include the next group, which is 3 cancellations. So you are going to ban customers who canceled 3 or 4 or 5 times out of 5 reservations. They total 5.79%. So it is up to you. Like, you cannot tell who is exactly the abuser or not, but anyhow, there is an order of suspiciousness. That's what we have in mind. We are going to rank the customers from the most suspicious group to the next and to the next, and then customer A will fall into the 5.79% group, right? So customer A is here. So customer A is here 3 times, cancel it 3 times. So customer A will be banned if you are planning to ban 5.79% of customers, right? So we are going to understand it as the ranking, customer A's ranking of suspiciousness. Ranking is represented as a percentage. So 0% means the most suspicious customer, and 100% is the least suspicious customer. Okay, so customer A can be understood as the top 5.79% suspicious group. Okay, it's a ranking. We rank our customers by their suspiciousness. Okay, as you see, customer A lies here, and so this much if you are planning to ban customer A, you have to ban all these groups, right? They are more suspicious. So remember this number. Now, we are going to do the same thing for customer B. The difference is customer B follows a binomial distribution, but the number of reservation is 100. So out of 100 times, 20% are canceled. So the distribution looks like this. Actually, there are positive probabilities here, but it's really hard to see because the probability is so small. So probability of canceling all 100 out of 100 is really, really small. That's impossible to happen. Nearly impossible to happen. So most of the probabilities lie around 20%. That is the expected number. So 20% cancellation probability imply 20 cancellations out of 100 reservations. That's where most probability lies. And it's like normal distribution. But anyhow, but following the same logic, we can see that obviously the more cancellations, the more suspicious the customer is. Okay? So we can place our customer B who canceled 30 times is lying here. Okay? So then let's think about the ranking. So customer B is here, and this much is more suspicious customers. The probability on the right hand side of the customer B is the ranking, the more suspicious group than customer B. So when you are planning to designate customer B as an abuser, you have to designate all the more suspicious guys as abusers, right? That is 1.12% if you calculate binomial distribution. Okay, so then customer B is top 1.12% suspicious customer, right? So it's now you can statistically compare who is more suspicious based on their rankings. So customer A is top 5.79%. Customer B is top 1.12%. So customer B is more suspicious, higher rank, right? So in other words, if you decided to ban 5% of your customers, 5% of the most suspicious customers, A will not be banned, but B must be banned if you are planning to ban 5% suspicious people. Okay? So it is more statistical approach to this example, right? And exactly this is the basic hypothesis testing idea. The main point is we are going to calculate this distribution, and this distribution is based on this assumption. We believe that everyone is innocent, right? That is our null hypothesis. We have to believe that all the people are innocent unless it's proven wrong, right? So if everyone is innocent, this will be the distribution. And based on the distribution, we have to decide how the ranking of suspiciousness. Who is the most suspicious guy and how suspicious a person is, like that. So based on that, we calculate the ranking as a probability from the top. Okay, that is what we are going to do here. And let me formalize this idea a little bit like using statistical notation. So what we are going to do is, our belief is that the cancellation probability is 20%, which means a customer is innocent, right? Our customer is not abusing free cancellation, but the customer had to cancel a reservation due to a reasonable reason, right? That is our belief. we have to believe them. But if this customer is too much suspicious, then we have to reject our null hypothesis and we think, okay, this customer is canceling too much, more than 20%. More than 20% is not a reasonable, not an innocent use like method, way of canceling reservations. So this is exactly what I explained earlier, the unfair, kind of unfair decision-making approach. Okay, then let me put more terminology on here. So first, you have to choose how much you are going to reject, right? That means how many customers you're going to ban. Like, I'm going to ban 1% or 5%, 10%, because I'm not sure how many of people are abusing the free cancellation policy. So it's your choice, literally your choice. And like that is called the significance level. It is pretty similar to the confidence level in the previous chapter. In like confidence interval estimation, we chose how much error we are going to allow. We may allow 1%, 5%, 10%, and we choose the confidence level according to that. So same idea. We have to determine first, we have to choose how much we are going to ban. And that is denoted as alpha, which was the same notation as the error probability in interval estimation in the previous chapter. So if you increase alpha from like say 1% to 10%, that means you are rejecting more. Higher alpha, the more rejections. It's your decision. And then second, now then after deciding how much you are going to reject, you need to calculate, you need to look at the data and calculate something that is called the test statistic, typically denoted as T. So test statistic is what we calculate from the data, and in our example, it could be the number of cancellations, right? A number of cancellations is the test statistic, simply speaking, here. But in the later, our general setup, we are going to use the sample mean. Sample mean is basically what you are going to look at, what you are going to calculate from the data. So that is test statistic that is associated with the data. And then we are going to calculate the sampling distribution of the test statistic when you believe the null hypothesis. Okay, so exactly what we calculated using the binomial distribution. So this is to calculate the ranking. Who is the most suspicious, right? And that is called the null distribution. This is a specific distribution, sampling distribution, if you assume that the null hypothesis is true, right? So earlier in our example, we used binomial distribution, but the point is we had to know the probability of cancellation, and we assumed it is 20% because we believe that everyone is innocent. And later, in our later applications, we are going to use the normal distribution. Like you know what's coming. We are going to use the central limit theorem and approximate the sampling distribution to a normal distribution. Then you will be fine. And then you calculate the test statistic from the data, and you calculate the null distribution from the null hypothesis under the assumption of the null hypothesis. Then we are going to calculate the ranking of the suspiciousness. That is the probability of more suspicious group or more suspicious values than what you calculate from the data. Exactly, that's the percentage we calculated earlier. We call that p-value, right? It's the ranking. If it's close to 0%, then your observation, what you observe is really, really suspicious. But if the p-value is close to 100%, then it's not suspicious at all, okay? So as I said, the point, like, this can be confusing, but again, remember, this is the ranking of suspiciousness. And the smaller the p-value is, the more suspicious the null hypothesis is. So you are going to reject the null hypothesis if the p-value is too small. Okay? Earlier, customer B was top 1%, customer A was top 5%, then A is more suspicious, right? And then how small is too small? That is your choice by the significance level. So if you choose significance level at 10%, then that is the cutoff. P-value less than 10% will be considered too small. So you are going to reject. So this is how we carry out statistical hypothesis testing. I hope this example shows you the basic idea. And you may want to read the like textbook definitions of those terminology, but definition is important, but it would be more helpful to understand the meaning of those terminology using those example. I hope you think about this example again and review those textbook definitions after understanding those examples. Okay, so far I tried to set up the basic structure and like would like to explain the basic ideas without much calculation. I focus more on the intuition. So in the next video, I will give you more concrete numerical examples using like normal distribution and more statistical techniques. So look forward to that and see you in the next video. Bye.